So some reactions. Draw and name the product when first of all butanol. So there's butanol there, or carbon aldehyde. Now one of the tricks with organic reactions predicting them is just to recognize them. So you see NaBH4, what's that? Well, NaBH4 is a reducing agent, so that's a reduction. This is an oxidizing agent, so that's an oxidation. And then both of these, ignore the cyanide and potassium there, that's just how you get the particular group in. But Cn minus, lovely nucleophile, N3 minus, lovely nucleophile, just like Cn minus. So recognize all of these reactions. You take an aldehyde, reducing agent, reduce it, oxidizing agent, oxidize it, and then something's got a nice nucleophile, and you should recognize a lot of those nucleophiles from nucleophilic substitution discussions that we had back with the halogen alkenes. So anyway, what happens when we reduce an aldehyde? We make a primary alcohol. So as we just did before, just turn aldehyde group now back into the primary alcohol because we're reducing. What would you call that? This one's 4 carbon primary alcohol, so butanol. When we oxidize an aldehyde, we turn it into a carboxylic acid. So just turn this one up here. The carbon double bond O is already there. Instead of the H, it's an OH. So there's the product, and that is, of course, butanoic acid, which we're going to learn to name properly in the next module. Now, then nucleophilic addition. Remember, you get the nucleophile attacking from the bottom here on this carbonyl carbon, making that a single bond O minus, and then when you've got an acid in there, it just protonates the O minus. So any nucleophilic addition with an acid, you're just going to have the nucleophile on that carbon and then OH there. So let's pop that in. That's the Cn with the OH, and then N3 minus with the OH. And we'll learn how to name these at some point later on in your lives, not necessarily in this course. Same idea now with acetone. There's acetone, and of course this is a ketone. So ketones behave very similarly to aldehydes in terms of nucleophilic addition, albeit more slowly, but the redox chemistry of ketones a little bit differently. First of all, reduction. Well, reduction is the opposite of oxidation. We've seen how you can make a ketone by oxidizing a secondary alcohol. So when you reduce a ketone, you get back that secondary alcohol. So take the carbon there that's got the double bond O and just turn it into a secondary alcohol like this one. So this particular one here would be 2-propanol. Now, what happens if we try and oxidize a ketone? Well, unlike an aldehyde, a ketone oxidation is the end of the oxidation string, and so there is no reaction. You oxidize aldehydes to acids, you do not oxidize ketones. Nucleophilic addition, same idea, addition of the nucleophile, be it Cn minus or N3 minus, making it O minus up here for the carbonyl, and then you have acid there to protonate it.